Getting to Mars. Yeah, that's one of the biggest challenges humanity has ever even thought about. But what if I told you that was the easy part? Okay, let's get into this. Because the dream of a round trip to the red planet, it's hiding a really brutal reality. The journey home is a nearly impossible puzzle of physics, biology, and psychology.
So, why would the first Martian explorers be on what is essentially a one-way trip? Let's break down the three huge reasons that you don't hear about much in the glossy mission announcements.
And just to be clear, this isn't just about getting stranded on Mars. The real challenge is that actually escaping the planet and then surviving that trip home might just be beyond what we can do right now. First, let's just look at the raw numbers, the basic mechanics of a return trip that, frankly, create an absolute engineering nightmare. It all starts with scale. We're talking about 140 million miles. That's the average gap between us and Mars. It's just a vast, empty void that takes a full 7 months to cross, one way. And it separates those astronauts from any possible hope of a rescue mission. And here's the kicker. You can't just leave when you feel like it. Earth and Mars only line up for a return trip once every 26 months. If you miss that tiny window, you are stuck on a hostile planet for another 2 years. You're basically a prisoner of celestial mechanics. Okay, so let's say you do hit your launch window. To blast off from Mars, you're going to need about 1,200 metric tons of fuel. That's the weight of like 200 elephants. It is way, way too heavy to bring with you from Earth. So, how do you get it? You have to make it there. That means landing an entire chemical plant on Mars, finding and mining for water ice, and then just crossing your fingers and hoping this incredibly complex, unproven technology works perfectly in a freezing, dusty environment 140 million miles from the nearest mechanic. Good luck with that. And this leads to the ultimate paradox, a real catch-22. To leave Mars, you need a big, heavy spaceship. But our technology today can't safely land something that massive on Mars. So we can't solve the leaving problem until we solve the landing problem, which, we haven't. But let's say you do it. You solve the engineering. You are a genius. Well, now an even more personal problem pops up. Your own body starts to break down in ways that could make coming back to Earth completely fatal. It all kicks off with gravity. Mars only has 38% of Earth's pull. And while that might sound kind of nice at first, after living there for 16 months, that seemingly small difference makes your body fundamentally betray you. See, your body adapts to this weaker gravity. Your bones lose density at an alarming rate. Your muscles just waste away, even with intense exercise. Your heart weakens. Your body is literally re-engineering itself for Mars, which makes it dangerously